answer to the free response number 2 on the AP Calculus BC 2017 exam, as done by Bryce and Kim for Miss Mente. So the first part wants you to find the area of R, and this is the graph that you're given. So we know from the instructions that f of theta is equal to 1 plus sine of theta times cosine 2 of theta, and we know that it's on the interval 0 is less than or equal to theta, less than or equal to pi over 2. So setting this up is simply a matter of setting up an integral from 0 to pi over 2. Now the two important things to remember is that you have to have the half in front of here, and you also have to square f of theta. So once you do that, it's simply a matter of plugging it into your calculator, and that gets an answer of approximately 0.648. And with that, you're done with part A. Now moving on to part B, it gets a little bit more complicated. What you're instructed to do is you have to draw a ray theta is equal to k, which I've illustrated in this graph right here. It's going to divide the area S into two regions of equal size. Now you do not have to solve this question, but you have to write one or more integrals to find the value of k. So from the instructions we're given f of theta and g of theta. And basically what we want to do first is we want to figure out how we would find the area of S. And the way that we would find the area of S is by doing g squared minus f squared. Now once you do that, you can have two integrals. You can set them equal to one another because once again, we just have to write it, we don't have to solve it. So moving down here, again, making sure that we have the half in front of both of our integrals, and then also making sure that we've squared each of our equations. Once we do that, we set one integral from 0 to k, and then we set the other integral from k to pi over 2. And then, if we were to solve for k, we would know exactly where that halfway, that ray that divides the area of S into two equal parts. And that's how you solve part B. So, now on to part C and D with Bryce.
Hey guys, it's Professor Bryce here, and I just wanted to explain part C and D of the 2017 question free response question number 2 of the Calculus BC exam. Part C explains for each theta from 0 to theta of pi over 2, let w of theta be the distance between the points for which the polar coordinates f of theta 0, f of theta, and g of theta. Write an expression for which write an expression for w theta. So, to understand this equation, you just have to understand the basics of how polar equations work. You have to understand that one curve minus another curve equals the distance between those two curves. So, our w theta expression is g of theta, the outside curve, minus f of theta, which is our inside curve. Then, it asks us to find WA, the average value of w theta over the interval of 0 to theta to pi over 2. Then you have to do, we know our average value function is 1 over b minus a from an integral of a to b of f of x dx. As we already found our w theta function, and hopefully you've stored these equations into your calculator under the polar coordinates, under the polar equations, you can do 1 divided by pi over 2 minus 0 from the integral of 0 to pi over 2 of w theta d theta. And this approximates to about 0.485. That's how you solve part C. Now moving on to part D, this gets a little trickier. It asks you to find the value of theta for which w of theta equals w of a. And at first it looks pretty complicated. But if you think about it, that's just which theta makes w of theta equal to 0.485, which we found this value up here. So you can do that by graphing both equations. You can do that by graphing w of a, which is 0.485, on your calculator, and the function w of theta into your calculator. And then find that first intersection point, and then you know your value of theta, which is 0.518. Finally, the question asks you the function increasing or decreasing at that value. And as we know, we find increasing or decreasing values by finding the derivative at w of theta. So, for part 2 of the equation, of part D, you would find the derivative of 0.518 of w theta. And using your math 8 function in your calculator, you can find that it equals negative 0.582. And then finally, it asks you to explain the problem to justify your answer. So, since W of theta of 0.518, which is what we got right up here, is less than 0, WT is decreasing at theta equals 0.518. Okay, kids, that's how you got it. That's the free response question 2 of the Calculus BC exam.